Hi friends, welcome to this class. In this class I am going to discuss about this diastereomers. See, I have told you that if this is the molecule, it is having plane of symmetry, so it is optically negative. Such molecules are called mesocompounds, right? And also see here H, OH. COH. Right? See here. The relation between this and this is diastereomer. Right? Why? See here. 1, 2, 3. 1, 2, 3. This is anti-clockwise since hydrogen above the plane. So it is R. And what about this? 1, 2, 3. 1, 2, 3. It should be R, but it is S. Since all our atoms are same, intercancellation, so it is optically negative, so mesocompound. What happens here? 1, 2, 3. It should be R, but hydrogen above the plane, so it is S. Here 1, 2, 3. 1, 2, 3. It should be R, but since hydrogen is above the plane, it is S. Right? See here. And also, if I place a mirror, I will get one more structure here. COH. COH remains as it is. OH comes here, H comes here because this is mirror. So OH here and H here. This will be definitely R and R. Just you check. It will be definitely R and R, right? The relation between these two is enantiomer. One is S enantiomer, another one is R enantiomer. The problem is, see here, both are having same melting point, same boiling point, same retention factor. So we can't separate. But this C, the relation between these two is diastereomer. And also relation between this and this is also diastereomer. If I able to react this with this is RS. Let me say I reacted, I got one compound, it is like R, S. Let us imagine, it's not true, but when I go with these videos, I will explain you how we are going to separate those racemic mixture. If we have this 50% and this 50%, how we are going to separate. But now, for momentary, for explanation, let me take. I reacted this with this and I got RSS. 3 carbons I got, one is RSS. Since it is SS, so SS remains as it is. It is having RS. However, I reacted, I got RSS. Let us assume. And also I reacted this with this and I got R. This was R. So again, these two are diastereomers. In case of diastereomers, what's the thing is, they will be having different melting point and boiling point and also the retention factor. See here, this and this is diastereomer. Both are having different melting point, different boiling point and retention factor. So I can easily separate. So to separate things, what we do, we react these enantiomers with one of the diastereomer. We will get the mixture which will be diastereomer. The mixture won't be same, it will be different. So these are having different melting point, just we separate. Let us assume that it is having 120 degree melting point, it is having 80 degree. So this fractional distillation we can separate. Once we separate, again however we do some reactions and we will get back the same. So we will get SS here and here R. Like this we can separate. So diastereomers, they will be having different melting point, boiling point and retention factor. This thing you should understand. And also I told in one of the video lecture, while explaining some topic, I told about Epimers and also you will learn about anomers I told in diastereomer. So we have two. One is Epimer and Anomer. What are Epimer? I will explain now, right? Epimer is also a diastereomer, Anomer is also a diastereomer. Let us see this epimer. OH, OH, H, OH, right? Like this you need to remember. OH, OH, H, OH. Wherever OH comes, H we should put. Wherever H comes, OH we should put. Down CH2S, CHO. This is D-glucose. Right? This is D-glucose. I will write one more molecule. OH, OH, H, H. OH, OH, H, H. Right? What I did, I kept all these three positions same. Only at this carbon I changed. So the difference between them is C2. At C2, this is 1, this is 2. This is 1, 2, 3, 4, 5, 6th carbon. So 1, 2. C2, there is change. So what is the relation between this and this? This is C2 epimer. And the name of this is, I think, mannose. It is mannose. D-mannose. D-mannose. The relation between D-glucose and D-mannose is C2 epimer of D-glucose. And also, if I change only one position, CHO as it is, CH2OH as it is, OH, instead of OH, let me write H here, again H, OH. The relation between these two is what? Where it is changing? Only at this position, right? Here it was OH, but here the fourth position is OH comes here. So this is the relation between this is C4. C4 epimer we call it. Epimers are nothing but diastereomers. Right? This D-mannose was C2 epimer of glucose and this is D-galactose. D-galactose is C4 epimer of D-glucose. This is about epimer. What are epimers? Epimers are diastereomers, no doubt, but only change at the stereochemical change at the only one of the carbon, chiral carbon. That thing you need to remember. There is stereochemical change only at the one chiral carbon. See here only at the C2 chiral carbon and here it is at the C4 chiral carbon. It is about epimer. Epimers are nothing but diastereomers but only change at the one chiral carbon atom. Next, let us discuss about this anomer. What are anomers? You know this. We have done these reactions, right? Anomers like, see here. This is ketone. If I place hydrogen here, it will be this, what is this? Aldehyde, right? And I will take this alcohol, ROH. It has having lone pair of electron. Since this is more electronegative, it can take its electron density. So it gets electron deficiency here. Delta plus charge comes on this carbon. And also this is sp2 hybridized. So all are in the same plane. So this alcohol group can attack above the plane or below the plane. It may attack like this also or like this since it is planar. sp2 hybridization, trigonal planar, no? It will be planar, so alcohol group may attack above or from below. If it attacks above, we will get 1. Let us see like this. OR, R, hydrogen, and here OH. One product we will get. The reaction, you know, as soon as it gives its electron density to here, it gets positive charge. So it removes that hydrogen, it will be neutralized. That hydrogen will be taken by this negative charge on oxygen. So it will be like this. If it attacks down, so it will be like this. R, H, OR and OH. Let us see, this will be R isomer and this will be S isomer. I told in some reactions we will get racemic mixture. See, this is the reaction. This is planar molecule and this is achiral reagent. When we reacted, we got racemic mixture. One was R and one was S within the same solution. If you want to separate, how I am going to separate? The separation of this racemic mixture is called resolution. That thing we will discuss in one of the next videos, right? So this is how we got this racemic mixture. See here, the product is called, since alcohol is reacting, the product is called hemiacetal. Hemi means half, acetal means aldehyde, the alcohol is reacting, so it is acetal. Both the reactions are called hemiacetal. So I was discussing this anomer. No, this reaction I simply gave you because this reaction you need to understand to discuss about this anomer. See here, glucose, the structure I wrote. CHO 1, 2, 3, 4. CH2OH. As usual, OH, OH, H, OH, H, OH, H, H. Since it is having lone pair of electron and this aldehyde, I took example, right? Aldehyde. See here, it will be planar structure. So this attacks like this. This takes its electron density here, right? So I can also show it like this. OH. Since it will be planar, it will be attacked by, see here, 1, 2, 3, 4, 5, 6. One, two, three, four, 5, 6, right? Then here C, O, O, H is there, this group, and everywhere this OH is here, this carbon CH2OH, let me write CH2OH, CH2OH, H is below the plane. From here let me write OH, H, OH, everywhere H comes OH here and H, right? See here, it gives this electron density here, it comes here. So I will get two kind of reactions. Since it is planar, one will be above the plane, one will be below the plane. So two products. It will be like this. See here. This is cyclic structure of this glucose. This is open circle and this is cyclic. One time I will get OH down, other time I will get OH up. Here I have written H, there you need to balance by OH, I mean you need to write OH. Here I have written OH, you need to write H. That thing you will do. See here. If it attacks one side, I got this structure. If it attacks above the plane, I got this structure. Right? So this I called it as alpha D glucose. Open chain we used to call this D glucose. Whereas there I called alpha D glucose. And this one I called it as beta D glucose. What is the relation between alpha and beta? These are nothing but anomers. Anomers are nothing but the diastereomers. Only stereochemical change occurs at this acetyl carbon. Acetyl carbon. This carbon is called as acetyl carbon. Only stereochemical change occurs at this acetyl carbon. One is alpha, another one is beta. Everything will be same, right? Such compounds are called anomers. Anomers are nothing but diastereomers. Only stereochemical change occurs at the acetyl carbon atoms. This is all about diastereomers. In next class we shall discuss this resolution, how to separate the R and S and how we will get R and S. That thing also we need to discuss. Till then, take care and have a great day.